Morning, everybody, or good afternoon, depending on which class you're in. Beginning the video, I wanted to start going through a few homework questions that I thought you guys might have questions on, or I got a couple emails last night about some specific questions. So I'm going to work through these questions before we get started in the lesson, okay? Because we are going through those two today, 6A, 6-9. It's very similar to what we did yesterday, but I want to go through some homework questions just to kind of work on that stuff we did yesterday. So the first one we're looking at, I guess it's lesson 6.6, it's number 19, okay? That was the one where they gave you log base 6 of a number or log base something of a number, and you had to use the two numbers, like the two logarithm values that they gave you to figure it out. All right, so I think they gave us log base 6 and then log base 6 of 9 for this one, maybe. I'm not for sure. But either way, you can't use the other number to get to 48. So you got to think of how can I use one of the numbers to get to 48. Well, 8 is the only one here. 8's the only one that I can divide from that 48 and actually use to get an answer. All right, so if I think of 48, think of 8 times what gives me 48? Well, that's 8 times 6. All right, and there's a little trick to this that I didn't show you yesterday that it's one of those things the book kind of assumes you know. So I didn't see that until we did the homework, and we'll do that again today. But okay, I have to break that apart into two logarithms, so it's going to be log base 6 of 8 plus log base 6 of 6. Because remember, when you have two things multiplying inside the logarithm, you break them into two separate logarithms with an addition sign in the middle. All right. Now, the little trick to this. Okay, we know that log base 6 of 8 is 1.6 or 1.1606. Now, this one right here, anytime you have the base of the logarithm matching the number on the inside, it pretty much cancels to a 1. Okay, so again, if the base, so that would be my 6 here, if that is the same as that number, okay, you can ask yourself, well, log to 6, or the 6 to what power gives me a 6? Well, 6 to the first power, all right? So if you have the base matching the number on the inside, it just cancels to a 1. So this will turn into, right here, it'll be 2.1606 is your answer. Okay, so 2.1606. That's your final answer for number 19. Okay? So the little trick to that was this part right here. Trying to cancel out that log, okay, because it doesn't really give you a value for it, but it turns into a 1. Okay? Now, number 40 is the next one I'm going to go through. All right? So move it over to the side a little bit. Number 40 is the other one we're going through for chapter 6.6. Okay, so we had to turn this into, or we had to solve for n here, really. Okay, so you had to condense the logarithms on both sides, and hopefully that'll get us to something that we can start to solve. All right, so remember yesterday in class I said anytime you see a number out front, that's going to become an exponent for the number inside of the logarithm. All right, so if I rewrote that, I have log 2n equals log 27 to the 1/3 plus log base 2 of 36. That guy right there, that's from last chapter. 1/3 power, that's cube root. So the cube root of 27 is just a 3. Okay? Cube root of 27 is a 3. That's what that 1/3 turns that into. So now I'm going to condense everything on this side here. Okay, I'm already condensed on the left, so I'm just going to rewrite that. And then on the right, I'm going to have log base 2. Since we are adding here, okay, addition means multiply the stuff inside. So it'd be 36 times 3. Well, that's 30, 60, 90. 6 times 3 is 18, so that's 108. Okay, then we got the same logs on both sides. You get n equals 108. All right. So that would be our answer there. Okay, so then jumping down to 45 here. On 45, we have to do kind of the same thing. All right? But there's a little trick that we can do here, and it'll save us some time. Remember what I just said right above on number 19 there. If I have a logarithm with the base as the same as the number inside, that just turns into a 1. So I can really rewrite this as log base 3 of a squared plus 3 plus 1 equals 3. And then I can move the 1 over pretty quick there. So I have log base 3 of a squared plus 3 in parentheses there, and then I have a 2 on that side. Alright, so now this goes back to like the things that we started with logarithms. We only have a log on one side, so that means we're going to have to change it back to an exponential. We have to exponentiate it, alright? So I've said that a couple times, you might not remember it. So we take the base to my exponent, okay, so it would be 3 squared equals the stuff inside the logarithm, a squared plus 3, and I really didn't need the parentheses here. I'm going to get rid of that parentheses. I didn't need it because it's over there by itself. Okay, so 3 squared is 9. Alright, so I want to move that 9. Well, actually I want to keep the 9 where it is. Alright, because I only have a single variable there. So the thing I want to move is that 3. I'm going to subtract 3 from both sides. So 9 minus 3 is 6. So we have a squared equals 6. And then that's something that's pretty easy to solve from there. Square root both sides. Now remember we have an even root. That's an even root because it's a square root. So we have a equals plus or minus square root of 6. Okay? And I can put both the positive and the negative square root of 6 in here because if I put it in here for that a squared, it's going to turn into a 6 regardless. Alright, not too bad so far. So on 6.7, we're going to start with 25. In a second here, I'm going to double check that number 40, see if it is 108. 40 is 108, so that's correct. It kind of seemed like a larger number, so that's why I wanted to double check it. Alright, so down to 6.7 here. We got 4 of them from 6.7 we're looking at. Okay, so 25, starting out with 25. I have 2.9 to the a minus 4 equals 8.1. So we have to solve that. So that was one of the ones we did kind of in the middle of class yesterday, where if we had an exponent that had a variable in it, then we could take the log of both sides. I can take the log of both sides, and that allows me to bring that exponent down. Alright, so I'm going to have a minus 4 out front of that, out in front of that log of 2.9, and that equals log of 8.1. Now, yesterday at the end of class, we distributed this logarithm. Okay, we distributed that through that parenthesis. Here, I would not. The reason we did that yesterday is because we had 2 variables in the equation, or 2 x's in the equation. Here, I would not do that. I would just simply divide it out over here. So divide by log 2.9 on both sides. Alright, so then that'll cancel it over here. And then you can see the only thing I'm going to have left to do is add 4 to both sides. Okay, because that'll cancel that here. So then A is going to equal this after you put it in your calculator. So remember, when you put it in your calculator, you're going to have to do this, close that off with parentheses, divide by this one, close it off with parentheses, and then add the 4. Okay, so throw that in your calculator, see what you get. Should be 5.9647. Okay, about 5.9647 after I throw that in my calculator. Alright, and that's okay that we got a crazy decimal like that because we're using these logarithms here. and it says round to the 10,000s. So we're at 10, 100, 1,000, 10,000. So that's fourth decimal place. Okay. Now number 30, we're gonna have to do the same thing because we have that. Oops, we have that that variable up there in the exponent. So I'm gonna have to take a log of both sides here to get that exponent down. So I take the log, then that 4x comes out front. Okay, so it'll be 4x log of 2 is less than or equal to log of 20. Now I'm going to kind of do two steps in one here because what are the two things that we have to divide on the left? We have to get rid of the 4 and we have to get rid of the log 2. So I'm going to divide that side by both of them. So divide by 4 log of 2 on both sides. Okay, because that's going to cancel over here. The 4 will cancel. And then we'll just be left with x is less than or equal to whatever we get when we throw that in our calculator. Okay, you guys should be getting fairly good at throwing these things, like punching them in your calculator. Because remember, we need those parentheses. Okay, so log of 20 divided by 4 log of 2. And you should get x is less than or equal to 1.0805 after I throw that in my calculator. All right? Let me double check to make sure that the answer key is right. Yep, 1.08048, so that rounds to 1.0805. Okay, a couple more. So these last two are pretty much the same as the things that we've just been doing here. All right, so we've got exponents up in the variables up in the exponents, log of both sides. You're going to have to do that over here also. We're going to have to take log of both sides, log of both sides. Okay? So then that gets my x squared out front. So I'd have x squared log 10 equals log 60. All right, so then how do I get the x squared by itself here? I want to divide by log 10 on both sides. So then I will throw this in my calculator. Okay, then to get the x squared, I'm going to have to square root that. So x is going to be equal to the square root of whatever I get when I throw these logarithms in my calculator. Okay, so it'll probably be a decimal. It'll be plus or minus whatever that decimal is. Okay, so the book says should be 1.3335. So x is about positive negative 1.3335. All right, 65, going on that one. And if you guys need a little bit more time to watch these or to watch me work through the problems, then the sub can pause it for you, and you can look at the work if you need to. I'm also going to send it to you guys, so you should be able to watch it in your free time. But for 65. Log of both sides like I did there, that allows me to bring this whole group down out front. Okay, so I have x squared minus 3 in parentheses, and then log of 4 equals log of 16. And I hope you can kind of see what you're supposed to do here. You don't want to distribute this, you want to divide by that log base 4. Okay, because that cancels out over here. And then we're left with this now. And I'm going to try to work through these all the time where I don't use my calculator until the very end with the logarithms. You could change these to decimals right here if you wanted to, but I'm not going to. All right? I'll do it at the very end. So next step, just add that 3. It's going to cancel over here. then we would have x squared equals all of that stuff right there. Okay, so I would need to actually put that in my calculator now, because I would have x squared equals log 16 over log 4 plus 3, and to get rid of that square, I'm going to have to square root both sides and then add a plus or minus. Okay, so you can kind of see that, yes, the calculator is going to help you out here, but we have to make sure that we punch it into our calculator correctly. So I would do this stuff first, make sure I get a decimal for that, log of 16 over log of 4, and then add 3 to that decimal, okay? Then take the square root of that. So that second answer key that we used yesterday, when you press that blue or whatever color it is, looks like this. Second, and then you press the answer, or I guess it was a negative button with the answer above it. This really comes in handy on these problems. So for 65, we should get 2.2361. So plus or minus 2.2361. Okay, and then that should be it. So take some time, like another few minutes if you need to finish up these problems. And if you need the sub to rewind these, then go back and you can look at the other questions up above or watch the videos. But then when you're done, turn it into the yellow bin up front. Okay? So please pause the video and take some time to do that. And then we'll get started as soon as everybody turns in their homework. Or the people that have it done. Alright, back to the lesson. So we're back to 6.8 or 6.8, 6.9. And I'm going to try to compare this to yesterday as much as I can. And I'll probably be skipping a few examples just to get you guys a little bit of time at the end, because I know last time the video was kind of long. Alright, so 6.8, 6.9, doing natural logs and solving log equations. Really, we've kind of looked at these already. Okay, natural logs, that's that ln that I wrote yesterday, or I said it was log base e. Okay, and I'll show you what e is today. And then solving logarithmic equations, we've kind of been doing that the last 2 days already, so it shouldn't be very much of a new lesson. Okay, so natural base e, I'm just going to tell you what it is right now, and I'm going to show you in a calculator, but that actually is kind of like pi. It's an irrational number that goes on forever, and I can get the number from my calculator. So it's 2.718281828, and then there's just more decimals that keep going on forever, okay? And that's not necessary for you to remember that. I just want you to know that that is a number. E is a number. It's not a variable. We can treat it like a variable just like we can pi, but it is actually a number. Okay, so now I'm going to show you a couple graphs here. We actually can use e to the x, which that's actually a button on your calculator, or e to the negative x, and it gives us a growth function. Okay? If we have a negative exponent for this one, like e to the negative x right here, then that is a decay function. So now, rather than thinking of, all right, that's a growth function, or, okay, this is a decay function, you're looking in the exponent. Okay? Positive exponents there, that's going to tell me that it's a growth function. Negative exponent right there, that negative x, tells me that it's a decay function. All right? So just know that e to the x is the growth and e to the negative x is decay. And I have the graphs here. This is what they look like. Okay? So just look at these graphs for a second here. Kind of translate it a little bit. So e to the x, looking here, and I'm going to switch to a highlighter quick. Okay, e to the x, right there, that is your growth function. Okay, that should look like something we've done before. And then e to the negative x, that's your decay function. That should also look like something we've done before. And then also graphed on here are the inverses, because these graphs kind of look crazy, but they just graphed natural log of x, which we've graphed logarithms. They look just like that red line. Okay, and then negative natural log of x. We've graphed stuff like those before. So those are just two new things, but they're pretty much what we've done before. All right, so looking back up here to that highlighted information, the inverse of a natural base exponential function, okay, that's just the e to the x stuff. Inverse of that stuff is called the natural logarithm. All right, that can be written as log base e, but it is abbreviated as that right there. That's what I want you guys to remember. I've shown it to you the past 2 days because I've given you examples with that stuff in it where you guys are like in or 1n, but it's actually ln. It's natural log, and I don't know why they didn't do nl. My guess is just because it's something, it probably comes from some Latin word that they did ln rather than nl, okay? So, that's just a little bit of information about e. Now, another little bit of information about e. We're not going to do this to figure it out, but e I said yesterday, that's actually called Euler's number, okay, or it's the exponential, base exponential function. I could use this equation right here and get a pretty good estimate of e, okay? So this is what I normally do to save you guys some time. I'm not going to do it, all right? So I would have a chart like that. It's kind of like an XY chart. And I would plug in each of those numbers. I plug in 5, 25, 50, 100, 500, 1,000, 3,000, and then we'd have to keep going. And then you could eventually see that we would get e to be that decimal once we started plugging in larger and larger numbers into that equation on the top. All right? So that's just kind of a fun way to figure out what e is and where it comes from. We're not going to take the time to do it right now, maybe some other day, but we're going to use it in our equations. All right? So on your calculator, it's kind of hard to see this on the projector. All right, this is the one right here on the left. This is the one that a lot of you guys have. Okay? The e to the x button is the same thing as the log, and it is really hard to see that on here. Okay, that natural log there, so it's over here where I'm highlighting. These are the buttons we've been using lately. E to the x is where the ln is, so it's right below the log button. So you have to press second and then e to the x. That gets you your e, all right? And then on the TI-30 here, the one on the right, so this one over here, it is right there where the natural log button is on there. Okay, so you have log and ln. It's right where the ln is. Okay, and then on the 84s, some of you guys have 84s, TI-84. The natural log is down here. Okay, and that's also where your e to the x button is. So if you can find that ln, then you know where e to the x is. Okay, so that's if I press that button. All right, so if I did second, this is just your keystrokes to get that because I have to press second because e to the x is above that. And then I press that button, and it would give me something like this maybe. E and then a caret, I press a 1, so it'd be e to the first power. That's going to give me that decimal, okay? So that's going to give me that 2.71828. That's going to give me that decimal there. All right, so that's what it is on the calculators. Now, we're actually going to use this in our equations. All right, so write this example down, and we're going to do a handful of equation examples now. So, looking at this one, we have an exponent that is a variable. All right, so just like all those homework problems we did, we can take the log of both sides. Actually, we don't want to do that here. My apologies. Okay, we want to change this to a logarithm. Okay, we could take the log of both sides and it would work out the same way, but that's going to complicate it a little bit. We want to change this to a logarithm. All right, so thinking about the way we changed exponential into logarithms before, my base is e. All right, so that means I would say it would be log base e. All right, so then e is my base, 23 is the stuff inside the logarithm, and then x is what's on the other side of the logarithm. So log base e, right there, I really don't have a log base e in my calculator, but I do have that natural log, which is the same thing. So log base e changes into natural log of 23. That's it. That's all you have to do. Okay? Now, if you wanted to go a little bit further and actually get a decimal representation of this, you would just press natural log, so ln. So find that button on the left-hand side of your calculator, for those of you guys that got the TI-30s. So press natural log of 23. That gives you about 3.1355. Okay? That's what it would give you. But we don't need to go that far because all we want is a logarithm. Okay, so we want to do this here now. So we don't need to get a decimal, we just need to change it to a logarithm. Alright? So, got my base of e there. Log base e of x equals 4, right? Because it's base, and then the exponent goes on the other side, and then the x is inside the logarithm. Okay? So if I have log base e, all I have to do is change that to a natural log of x equals 4, then you're done. Okay, that's all you got to do. We're just changing them from exponential equations into logarithms again. That's the first thing we did when we worked with logarithms. All right? So now we're actually going to do a little bit of stuff that we did yesterday. Okay? We didn't do it with natural logs yesterday. We did it with normal logs, common logs. But now we're just going to do it with natural logs. So this is pretty much review. Okay, so take a second to write that down and then condense it. Okay, so we have the number out front, the 4. Remember, numbers that are out in front of logarithms go up top as exponents. So I can rewrite this as natural log of 3 to the 4th plus natural log of 6. So then you know that when you add these, then you are going to multiply the stuff on the inside. So natural log of 3 to the 4th times 6. So that's going to be kind of a bigger number, because 3 to the 4th is 81, right? That's 3 times 3, which is 9, times 3 is 27, times 3 is 81. Now 81 times 6. So 80 times 6 is 240. No, it's be 480, so it's 486. So it's natural log of 486 if I multiply that out. Okay, I'm going to double check 81 times 6, that gives me 486. Yes. Okay, so that's my single logarithm. Alright, if we wanted to check a calculator to verify that, then we would punch all these into our calculator. I'm not going to do that, I'm just going to save some time. Alright, so I'd punch those in my calculator. That should equal the same thing as if I did natural log of 486. Okay, so take some time, see if you can figure out how to condense this one. So please pause the video and work through this example. Alright, back at it. So 2's go up top, or that 2 goes up top as an exponent. So that's natural log of 9 plus natural log of 4 plus natural log of y. So then from left to right, we're adding everything. So that means we're just multiplying everything. So it'd be natural log of 36y, right? Because 9 times 4 is 36. And then y just gets tacked on the inside there. Okay? So this one would be the same way. I'm just going to skip it for now. So now, solving equations. I have equations and inequalities here. To solve logarithmic or natural log equations and inequalities. This is, again, this is just what you guys had on the homework yesterday, so this is more practice. All right, so the first one here, A, write the equation down, and then we'll solve it. Okay, so we have 2 natural log of 5x equals 6. So now we're actually going to get a decimal here. All right, so I can't exponentiate this, or I can't turn it into an exponential until I get the logarithm by itself. So that 2 has to go. If I rewrite this down here, my first step would be to get rid of that 2, because I can't change it to an exponential until the numbers out front are gone. All right? And then, so 6 over 2, that's 3, so we have natural log of 5x equals 3. Now I can change it to an exponential, because natural log is base of e, so I can rewrite this as e, that's my base, to the 3rd power, that's my exponent, equals 5x. All right, so now I'm just solving for x here, so I divide both sides by 5. So I get x equals e to the 3rd power over 5. All right, and then I would just punch that in my calculator. So find that natural log button, so you press second, natural log, all right, so second, and then that ln button, because that's going to give me the e to the x, and then I do 3. Okay, I'm punching a 3 in there. That would give me, so if I'm just doing the e, that gives me about 20.0855, and then I have to divide that by 5. Okay, so we get about 4.0171. So that's your answer. And I could plug that in for x if I wanted to solve or double check it. Okay, I could check for extraneous solutions. Okay? So down here we have an inequality. So looking at this one, go ahead and write it down. Looking at that one, do I need to do anything as far as getting the natural log by itself? No, I don't. Okay? Natural log is already by itself. Okay? We can do this a couple different ways. I'm going to do it the way that's a little bit more difficult, so that way we can see it. But right here, I'm just going to exponentiate that right away. Well, let's see if I want to do it that way or not. That would give me... I don't want to do it that way. So think, okay, I'm going to do it the easier way. What can I do to this logarithm, or the exponent of the logarithm? I have that exponent of 2 out there. So what can I do with that exponent of 2? So I don't want to FOIL. I would much rather bring that 2 out front, which I can do. Okay? Because that is way easier than foiling that stuff. Now, not always will I be able to do that. I can here. That's the first thing you want to try. Okay? If you try that and it doesn't work, then you're going to have to FOIL it. So then I want to get that natural log by itself. Boom, 2's cancel. This turns into a 4. Then I got stuff just like I had on the last example. Okay, so I have that. That's a base of e. So that means I can turn that into an exponential. So it's e to the 4th, okay, base to my exponent is greater than 3x plus 1. So now you should be able to see the quick and easy steps here to solve for x. So I'll subtract 1 from both sides. So e to the 4th minus 1 greater than 3x. Divide both sides by 3. All right, and I said greater than before. Remember, you read from the variable. So it's x is less than e to the 4th minus 1 over 3. And then you would just put that in your calculator and get a decimal. All right, so when I do that, x is less than, so e to the x, that's e to the 4th minus 1 divided by 3. Gives me about 17.8661. Okay? So that is my answer for that equation. And again, you can check it. You can throw it in there and see if you put that in there, are you actually going to get numbers that are less than that. Okay? So, moving on to more equations. Okay, we got a few more equations here. And I'm probably going to skip the brain break today because I don't know if you guys do it or not. If you feel like you want a break, you can do that. You can just get up and stretch. We can do this stuff when I get back. Maybe on Friday we'll try it. okay, rather than taking some time to watch the video. So if you want a break, please ask to pause the video. You guys can get up and stretch out, and then we'll do a couple more examples and get back to the work. All right, so this is the stuff that I talked about in the example at the beginning. All right, so if I have this and this, okay, you don't have to write this stuff down. We already did that. We did that when we first looked at logarithms. We knew that if we had a logarithm, we could change that into an exponential. Okay? This is really the new stuff that I want you to write down right here. All right? And then this one also. So log base b of b to the x just equals x. And then b to the power of log b of x equals just an x. All right, so this is the way that we can solve these exponential equations. And really it's just something like you don't have to use, like here it says take the log of both sides, log base b of both sides to cancel the exponential. And then the other one is we can raise both sides of the power of the base. Okay, we'll look at those and see if we actually have to do them here. But I do want you to realize that if you have the same number in the base as I do the logarithm, so the base and the logarithm number match, that logarithm just cancels out, and I'm left with whatever I have left there, which is the x. All right. So if I had log base 6 of 6 to the x, which is what we had in the homework questions, that would just go to an x. Okay, that would all cancel out, and that'll leave you with the x. Okay, so you don't have to write down all this stuff in the yellow boxes if you don't want to. You just kind of glance at it quick. Okay, and then we're just going to solve these equations here. So looking at these two, we actually did an example just like this yesterday. So ask yourself when you look at these, do I have the same logarithm on both sides? Here we do. So if we have the same logarithm on both sides, and there's nothing else separating them, okay, you can just go ahead and cancel that off, and you're left with whatever you have left. Okay? So that's a pretty easy step to solving these logarithms. But we're not done yet because we don't actually have an answer for x, right? So you see an x squared and an x and a number, so that means we're going to have to do some factoring here. All right, so I'm going to take these on the right-hand side and move them over. And then I'm going to rewrite it like a quadratic, because that's really what this is. And then we're going to look at that and see if we can factor it. What two numbers? Multiply to give me an 8. So if I listed factors of 8, that would be 4 and 2, 8 and 1. Which two of those are going to add to give you that 6? It's the 4 and the 2. Okay, so then problem factored, you get your answers from here. X equals -4, x equals -2. Now you're not done with these because we have to check them, all right? Because we have to check for extraneous solutions. Remember, the things that we cannot have inside of a logarithm will be negatives. You can't have negatives inside of a logarithm, all right? So plugging these in, the -4, all right, this would give me a 16 if I plug in -4, and then this would give me this one right here, if I plug in a -4, would give me a 24 minus 8, which is log base 4 of 16 in both of those. Okay, so we're good there. Let's check the -2. So if I put a -2 in there, I get a 4. I put a -2 in here, I get a 12. So 12 minus 8 is 4, which they are both good. Okay, so those both work. See if you can solve the next one. So pause the video, please, and write that one down and see if you can power through it. All right, so looking at that one again, you have the same log on both sides, log base 4. Cancel it out. Boom, boom. Then we're left with x squared equals x plus 20. So we have an x squared, an x, and a number. Put everything on one side and factor. Okay, two numbers to multiply to give you a 20 and add to give you a 1. All right, well, you can list factors of 20, or you can just know that 4 and 5 are 20. You do 5 minus, or 4 minus 5, you get a negative 1. So it'll be x there and there. We want a negative 5, positive 4. All right, and then we get an x equals 5 from there. X equals negative 4 from there. And we're going to call it good. We're not going to check those ones. Okay, so those should be your two answers. All right, so solving a logarithmic equation here. I'm going to show you two ways to do these. All right, and either way you want to do it is your choice. Now, we can do these equations just like we have before. All right, so I'm just going to change it from a logarithm to an exponent, or exponential. So I take base to my exponent, right? 8 to the 4/3 equals x. And then I actually have to evaluate this. So 8 to the 4/3, you got to remember how to do those. Okay? Well, the bottom number, that's your root, or your index, and the top number is your power. So I want to take the cube root of 8, and I'm going to raise that to the 4th power. So cube root of 8 is a 2. 2 to the 4th is 16, so x equals 16. That's the first way to do it. Okay? The second way is using those inverse properties that I had you guys write down with the big yellow boxes below it. Okay? So this way is called exponentiation, or it's another way to exponentiate. I want to cancel out that log. So you look at the base. All right, I'm looking at the base of 8. So, in order to cancel out the log on the left-hand side, what I'm going to do is I'm going to say that I'm taking both sides as a power of 8. So I'm going to say 8 has a power of log base 8 of x, and then 8 has a power of 4/3. All right, so if I rewrote that here so it looked a little bit better, that's what it would look like to exponentiate. I take both sides and I put them as a power of that 8. All right? So that inverse property here said that if I had an 8 there and a log base 8, that those would both cancel out and I would just be left with an x. And then the stuff on the right is 8 to the 4/3, which is exactly what we had the other way to do it. Okay? You can do it either way. Sometimes it's more beneficial or it's easier to do one way versus the other way, but they both work out the same. Okay? So I'm going to do it the new way for this second one. So go ahead and write that one down. Okay, we have log base 27 of n equals 2/3. So to do this the new way that I just showed you up there, you look at the base. Now I'm going to raise both sides as a power of 27. So I'd have 27 with log base 27 of n equals 27 to the 2/3 power. So this right here and that right there, those cancel, and I'm left with just an n on the left-hand side. And then you have 27 to the 2/3 power. So that is cube root of 27 squared, okay, which is just 9, because cube root of 27 is 3. Square it, you get n equals 9. Now, the way that this may become a little bit beneficial is if you forget how to change from a logarithm to an exponential, which I hope you don't because that's a lot of the chapter, then you should know that you can just raise both sides of the power of the base and it'll cancel itself out. Okay? If you like to cross stuff off, that's what I would do. Okay, a couple more equations. Hang in there. So, solving base E equations. So we're using that Euler's number again here. And I'm just going to do one of these, that way you guys can see it. And then I'm going to do 2 on the next slide. Okay? So I have this first equation I want you guys to write down. We're just going to do one of these again. So make sure you're paying attention. Put your phone away if you need to. Shouldn't have it out anyway. But what you want to do, okay, normally if we had a variable in there, I would say isolate the variable. So that's what I want to do first. I want to get the thing with the variable by itself. So the thing with the variable here is that guy right there, that e to the negative 2x. So you have to do reverse PEMDAS to get that by itself. So I need to subtract the 4. All right, so I'm going to rewrite it down here. That way I can do some work below. So subtract 4, and then you get 3e to the negative 2x equals 6. Okay, then divide both sides by 3. Then you get e to the negative 2x equals 2. Okay, now from this point forward, you could change it to a natural log or a logarithmic equation and then solve it that way. I'm going to use the inverse property, those things in the box that I just showed you guys, because I think it's easier when you're doing these. Okay, so rather than, yesterday we took the log of both sides here, now I'm taking natural log of both sides. All right, because remember what I showed you guys earlier in the video, natural log is base e. If I have the same base as the number inside the logarithm, then that whole thing cancels out, and I'm left with just what was there. So I have negative 2x equals natural log of 2. So that really simplified the equation, and I just divide by negative 2. Okay? So then you're going to have to use your calculator to get a decimal here. So I'd have x equals, so I punch in natural log of 2 divided by negative 2, you get negative 0.3466. All right, so since I'm just doing one of those, if you need to pause and rewind, that's okay, go back and check it out. But I'm going to jump to the next example just to save some time, so that way you guys get a little bit homework time. Okay, last ones here, we're going to finish up with these. I lied. We got continuous compound interest. Okay. Do these equations, and then I'll show you an example with continuous compound interest. You should be able to figure that one out on your own because it's simply plugging stuff into an equation. All right. So I'll do the first one. I'll do A, and I'll do C. Okay. Same way we've done before. Change this to an exponential. So 6 to the negative third less than x. Pretty quick and easy. All right, so, what's 6 to the negative third? Well, that's 1 over 216, so x must be greater than 1 over 216. All right, I'm going to double check something quick here. So on the next one, you're going to do it the same exact way. You would just raise it as a 4. So it would be 4 to the 4th is greater than or equal to x. All right, now I think I missed a step here. So when I evaluate this, since looking at the beginning of the equation, okay, I did not change my sign. Looking at the beginning of the equation, I have my arrow pointing at the x. Okay? So when I change this to a exponential, I want my arrow pointing at the x. So pointing at the x. All right, so then it would be x is less than that. So then I say x is less than 1 over 216. And I chose this example because there is a little bit more to it than just that. So I know x is going to be less than 216. That just comes from that changing to an exponential. Now think about logarithms again. What can you not have in logarithms? Because if I say x is less than 1 over 216, that goes lower than 0 or goes below 0. So I know I can't have negatives in here. I know I can't have 0 in there. So it's actually a compound inequality that I'm saying x is between 0 and 1 over 216. All right? So the other one here, if I do this quick, so it'd be 4 to the 4th is, like that, because I want the arrow the same way in respect to the x. So x is greater than that. So if I say here x is greater than 4 to the 4th, so x is greater than or equal to 256. They're pretty quick. Okay, and then you're also going to see some like these down here. And then these have a little bit more to them as well. So go ahead and write it down, and then we will work through it. All right, so looking at this, same thing we had before. Do we have the same log with the same base on each side? Yeah. So boom, boom, cancel that out. Then we have 7x subtract 6 is less than 4x plus 9. From there, you solve it just like a normal inequality. All right, so I'm going to put the x's on the left and then put the numbers on the right. So it'll be 3x is less than 15, x is less than 5. Okay, and then you need to check and see what numbers you can actually plug into the logarithm to see if there's a lower constraint there, because x is less than 5, that implies that we're going to negative numbers, and we know that we can't do that, right? So we need to check these logarithms. So just solving these, think of these right here, this and this, just like when we solved our factors, when we found those numbers from the sets of parentheses. All right, you can set it equal to 0, and then you can get your answer that way. So it's x equals 6 over 7, right? So this would give me 6/7. This one would give me 9/4, or negative 9/4, sorry. So I know that I can't use the negative 9/4 because that's a negative number. So that means I'm going to have to look at the 6/7 here. So that's going to be my lower number. So my x is going to be greater than 6/7, but less than 5. Okay, so remember that 6/7, that comes from the set of parentheses up here, and that doesn't look like a very good 6/7. That comes from that, just solving it like a factor. All right, now last thing. I'm going to be really quick with this, that way you guys got the homework time. This equation you want to have down in your notes, continuous compound interest. Okay? So A equals P to the R, PE to the RT. Think of it, PERT. P-E-R-T, PERT. All right? So P here is your principal. We've done that before. E is that Euler's number, so that's the button in your calculator. R is your rate. T is your time. Okay? So we're just going to do this example here. You're going to see actual word problems here. And we're not going to calculate all those. We're just going to do a couple of them just for practicing the calculator. So, say for this example, I'm depositing $4,000 in the bank. $4,000 in my bank. All right, so I know it's continuous. That's the word you're looking for here to determine if, or to determine which equation you're going to use or which formula. If you see something that says continuous compound interest, before, when we used that other formula with compound interest, it was just like quarterly, monthly, yearly. This doesn't say that, it just says continuous. So whenever you see continuous, that means it's going to be E. It's PERT. Continuous is PERT. All right, so 4,000 E. My R is 6, so I know that I have to do 0.06. And then my time is 1. We're just starting out for 1 year. Okay, so if I threw that in my calculator, $4,000, putting that in there for 6% for a year, that'll give me a decent amount of money. 3.5, that'll give me that. So I think that I get more money with continuously compounding interest versus the monthly or quarterly or something like that. Continuous is better. So when you see an account that says compounding continuous, you want that. All right, so just for practice, do 5 years. All right, so throw that in your calculator for 5 years. So you can press up on your calculator to get your equation back. This is what it would look like if I wrote it out. Okay, but the nice thing about this is that it automatically gives you parentheses for that exponent. So when I do this one in my calculator, I get 53.9944. Okay, so that's your answer. So you're going to see some word problems with these, but you're going to be looking for continuously compounding interest. All right, so make sure you read carefully. So it'd be something like this. We're not going to do this one, but I see compounding continuously. That means that's going to be PERT. Okay, so be aware of that. All right, there is your assignment. Hopefully you have some decent time to work on it. Let me know if you have questions on the homework. Okay, send me some emails. I will be responding. Okay, so good luck.